Good morning, dear students. So last session, we have taken a frame for sway analysis. We have solved for sway force, which has come to 19.25 kilonewtons. The meaning of that one is you need 19.25 kilonewtons force to stop sway. Okay. So to continue this session, we'll go for sway analysis. So in the procedure, it is told that you have to assume some arbitrary moments due to sway. That means, so you take a frame. This is a frame that is given. So imagine that the frame has got swayed. So we expect some moments develop like this in columns. Okay. So you see, because of this right hand side towards right sway, so towards right hand side sway, okay, right hand side sway has developed the moments in anti-clockwise direction. Okay, so anti-clockwise moments have been developed. If the sway is towards left, then the moments will be clockwise. So all are anti-clockwise. You can see all the moment developed at A and B in column AB, C, D column CD, all are anti-clockwise. Okay, so all are negative moments. So how do you assume the values? They are by the ratio of their sway moments. Okay, so let us take ratio. Say column 1 fixed end moments due to sway, column 2 fixed end moments due to sway. So take the ratio 6 ei delta by L square, 6 ei delta by L square. So 6 times, this is I, the moment of inertia of AB. Okay, so L is 4 meters, so E same, so E goes cancelled, delta same, so delta here as well as here also, same sway value. So delta same, only I1 by L1 square, I1 is I, L1 is 4, I2 is 2I for column CD, L is 8, so the ratio is 2. So the moments that you assume should be in this ratio. You assume any value. Okay. So which means what? M1 fixed moments means column 1 fixed moments. If you take 100 and M2 no should be 50. So likewise, if you assume M1 value 50 here, okay, then this should be 25. Because this divided by this 50 divided by 25 will match with the ratio 2. Okay, so you take moments of any values, like if you take this as 10 and this should be 5. So there is no hard and fast rule that you have to assume only 150. Okay, assume any values in this ratio, right? So the moments now are MFAB and MFBA. Correction here, MFAB, MFBA is equal to minus 100, and CD and DC values are minus 50. Okay, this is how we are going to assume the values to satisfy this ratio. Okay, now again the distribution factors, same, you bring the same table here because there's no change. in the members I values or spans, so no change. So same distribution factor table, you can use it, no worry. Okay, now the distribution table will change. So fixed in moments now are -100, -100. BC, there won't be any sway moments, 0 and 0, whereas CD -50, -50. Okay, because BC will not bend. BC will, before sway, after sway, it is straight. No bending. Okay, beam will not participate in sway phenomena. Right. Okay. So now with these values of -100, -100, 0, 0, -50, -50. Why you have got minus values like negative values? The reason, because sway is towards right, the moments developed are anti-clockwise. That's why all are negative values, right? Okay, so going for distribution process, joint B, the remaining value is -100. So add +100 there. So how much at B in AB is 100 into 0.33, 33, 100 into 0.67, 67. Here -50 is the balance, add +50. How much to C in BC, how much to C in CD, that will be decided by these distribution factors. Okay, so likewise balance it, then go for carrying to the far ends, because all are no rigid joints that you assume. Okay, so A and D are fixed anyhow, and B and C are assumed rigid joints. So likewise, we continue with balancing and carryover, balancing and carryover, balancing and carryover, till the difference becomes almost negligible. So that's how you get the end moments, which are arbitrary sway moments, we call them, because these are not the exact values. These values are not exact values. Okay, okay. You have to correct them to the correct values of moments, because you have assumed some values. You have to correct them, right? How? By correction factor. Okay, so you know how much sway force is required to stop the sway. So the same sway force, if you are able to produce, then you are going to get correct sway moments. Okay, so let us see that. So if you know that for which value you have got these moments, okay, and you know what exactly the sway force is going to come from the earlier analysis. So for that value, if for a particular value of s dash, this is a moment, and for a value of s, what is a moment? Likewise, you have to change these moments. So again, go for column AB free body diagram. So the values are -84.55, -69.1. So both are anti-clockwise, and the load is again 20, and that shall not be taken. Take only sway. Okay, as to just to represent the free body diagram, I have just taken drawn the load. You see in the equation the 20 is not appearing because it is already being considered when you take the calculation for S. So as I said, loads shall be taken separately, sway should be dealt separately. So we are now talking about sway. Okay, so that's why 20 will not come into picture. Just to show that the free body diagram, 20 is drawn. Okay, even there is no problem if you just don't draw this one at all. Okay, so HA horizontal reaction at A due to sway. HAS is written there. Okay, so HAS value minus 38.4125. Okay, taking moments about B, you write anticlockwise moments positive will give you this value. Similarly, you take column CD, you see the values of moments there, minus 44.4, minus 46.94. Okay, so CD, okay, HDS is taken just to represent sway analysis. So same again here, anti-clockwise positive is considered, HDS is now the value. Now the total arbitrary sway force. Okay, so this is the free body diagram. As you see, no loads are being taken. So HAS value, HDS value, and S dash value. Okay, so this is a sway force, arbitrary sway force calculation. Sigma Fx0 shall be used here. So HAS substitute the value, HDS and S dash, that is equal to 0, right, for now equilibrium. So S dash is equal to 49.83. Whereas to stop sway, you just need 19.25. But for the moments that you assume, the force is coming to be 49.83. So if 49.83 is developing minus 100 and minus 50, how much this 19.25 will develop the moments? That is how you are back calculating the values, or in the sense you are correcting the values of assumed moments. Okay, so you have assumed some moments and got some final moments. So these final moments are from these assumed values. Okay, so now to correct them, you have to multiply those values with this correction factor, S by S dash value. So how to do it? So again, have a table there. So now these are non-sway moments. Then these are arbitrary sway moments from assumed moments. Then this is the correction factor. So row 2 values must be multiplied with k value, means minus 84.55 multiplied by 0.386. Same way 69.1 multiplied by 0.386. So all these values are corrected. So these are corrected sway moments. These are arbitrary, just assumed. So final moments means add these two. Okay, add this and this, 1 and 3 rows. Add 1 and 3. These are final end moments. Okay, so now you can just draw BMD for this. So this is how moments are being represented: minus 28.54 anti-clockwise, plus 0.23, plus 0.23, minus 0.23. Minus, then minus 27.4, minus in the sense anti-clockwise. So for this, how you draw moment, we have already been practiced this, how to draw BMD. So just draw an arrow from the column line in this direction. So which means it is going to push this point outward. So have the ordinate. Then this is going to be, this is the line, extended line from column. So again, it is going to be clockwise. So it is going to push this point away from this. So this is how you are going to join these two. Same way here. Okay. So likewise, you have to draw these diagrams. So this is say this diagram is for support moments, the end moments that you have found. This one also. And span moments, you have got point load on AB, same simply supported beam you take, then draw BMD. Same UDL you have got on BC, draw BMD for UDL, then just hatch the portion which is left over, something like this. Likewise, okay. So this is the final BMD. Okay, so that's how we perform sway analysis. Okay, so just to recap once again, you are going to solve the frame by separating non-sway analysis and sway analysis. So first perform non-sway analysis, like assume some support here, beam level, so that the frame will not sway. Then go for moment distribution, find S value, which is the support reaction, means to stop sway, how much force is required. Okay. Then again go for assuming some moments in the ratio of no, sway values, like moments developed due to sway. Then assume some moments, then take arbitrary values in that satisfying ratio, then perform the moment distribution, find S dash by free body diagrams of columns and then total free body diagram of frame, then find sway correction factor, then multiply this sway correction factor to the end moments found from sway analysis, then to get final end moments. Final end moments. Okay, you have to add non-sway moments that are found from non-sway analysis with the sway moments which are corrected with correction factor. Okay, to get final end moments. Okay, so a bit lengthy, but moment distribution method is now to be preferably the procedure is to be followed like this, right? Right. Thank you. So maybe you can follow for the frame to to take this. It's already being taken, I think. So analyze the portal frame by moment distribution method. Yeah, this is being solved. Okay, done. So I just mentioned. Now, the earlier problem, we have just considered it as to be same as 4 meters. Now you can just assume in the other way, that use this convenience to make it a sway problem. So 5 meters EAB, then 4 meters BC. So take this problem as assignment question. This is 5 meters, 4 meters. So correct the problem with this 5 meters again, BC. Earlier we just mentioned this as typographical error, and we have taken 4 meters of same height and then we performed non-sway. Now it is just to take our advantage to take the advantage of this. So I just take 5 comma 4 meters, AB 5 meters, CD 4 meters. Okay, so that it becomes a sway frame. So perform this example. Remaining things are very similar. So UDL you have on BC, all that is same. BC carries UDL. Okay, so take this problem with the correction like this instead of 54 meters, which is abnormal. Okay, then perform this as sway frame for practicing. Right. Okay. Thank you.